So this is the lawn tractor automation meeting, and if you go down to the bottom of the screen of the YouTube, there are open up the description, and there's lots of fun links there you can look at, and it'll one of the links will take you to our automation page, which is showing right now. So if I move on, and I wasn't on the meeting last week because my power was out, and after the thing, I showed Al my new measuring stick that I'm working on. So I'll go through a quick description of that. Let's see if I can remember how to get this stuff back now. Let's go to here. So anyway, over Thanksgiving, Ardusimple had their Black Friday special, which they said it was a Black Friday week special. And I ordered one of these boards. It's the Ardusimple 2B or the Simple RTK 2B board. And if you order it as a kit, you get the antenna with it. And the antenna, even though it looks like the small antenna, how can I do this? So here's the that's just not working out. So this is an actual Arduino, which is the same size as that board. And so the patch antenna is bigger, even though in all the pictures they show it as a very small antenna. So let me go back to here. So see in this picture over here on the screen. Oh, you didn't see that because I'm sharing my screen. Am I not? So anyway, if you look at this picture, you can see the board and you can see the antenna next to it, and it looks fairly small. If we come back here, and now it's working better. So here it is in comparison to the board, and you can see the thing is almost as big as the board. So it's deceptive that they show it that way. So I was surprised when I took it out of the box and saw how big it was. And I don't know if any of that came through. Let me try a close-up view here. This is basically the size, the size of the antenna, and then compared to a survey grade antenna. You know, the antenna is this big, so it is somewhat smaller if you're trying to put it on a smaller vehicle, or maybe just make it a base station. You might want to use one of those. So we go back to, let's see, your screen. Go back here. Okay, so back to this story. So I ordered up this board, and basically I got the patch antenna for free. So for $189, I got the board and the antenna, and I can say, well, it's not really a great deal. If you don't need the antenna, it's not a great deal. But I needed at least one antenna because I want to compare the survey grade antennas to the patch antennas. So I ordered that up, and then what's the next thing I got here? So I ordered another. Well, here's a write up on that multiband antenna we were just looking at, and then here's the. So here's the antenna, which again is it's just one of these, which I guess now I'm sure, and I can't move back for it anyway. It's one of these antennas that I've already got two of those on the robot, and this is a third one that I've got. So, and this one's like $97, $98, and you get the antenna and a cable with it. They give you all kinds of diagrams and stuff here with it. And then I also got I didn't buy this time. This is the last time I bought one. I got one of these adapters. This is something that screws into the bottom of the antenna, and then gives you a 1/4 20 thread, and then that'll screw onto a tripod, or you can just use just a plain old 1/4 inch bolt to put in there. Just a standard American thread on that. And it turns out that they want $11 for it. So if I needed one right now, I could buy it for $11 and then pay DHL shipping from Spain, which is another $13 to $20. Or if you go to Amazon, you can buy two for $7.59. So they come out to be about $4 a piece with free shipping, and they're just cute little. Well, again, you can't see that, so it does the same thing. And if you got your antenna, stop sharing. Okay, so you get your antenna just on the bottom. It's got that standard 5/8 inch by 11 threads on the thing. So you take your little adapter, And you just screw it right on there. And now you got 1/4 inch threads, and then that'll screw right onto a tripod. Or as they say, you can just put a standard 1/4 inch bolt in it. So when I'm bolting on the robot, I'll just drill a 1/4 inch hole and put that on. Or if you wanted to, you could just get if you're able to do so, you can just drill a 5/8 inch hole through whatever in your base plate and put a big bolt up into that. You just have to find a short one because you don't have a lot of threads up inside of there. So that was something else I found out that after I ordered the thing, I thought, oh, I've got some of those spare adapters because I bought like 3 or 4 when I placed my first order to Ardusimple. But of course, they're in a box and I can't find them anywhere, so I had reordered new ones here. So let's see, my story was the point. Okay, I got that adapter so I can screw it onto something. And then I guess the next thing was, oh, I was going to pull up a picture of my tripod thing that I got. So anyway, I've got this thing called a monopod, and it's like a tripod, but it's just a single leg. So you can fold it up so it's like 2 feet long to carry it around. And it's got these things at the bottom where you can loosen that up, and it'll extend out to, I think it says 67 inches. And with the antenna, that puts the antenna like 69 inches above the ground, or 175 centimeters. So it's just maybe just slightly taller than me than when I got it fully extended. And the reason you want it long is because if you're too close to the antenna, that'll screw up the antenna. Your body being close to it can screw it up. Or if your head's up high enough, you're going to block some of the satellites. So it's nice to have an adjustable to be able to do that. So the whole point is I want to build one of the surveying poles like surveyors use. So I just wanted to make this thing portable. And after I bought my boards and my antennas, they're laying around. I thought, well, what would be the quickest way to test these and get them running? And I thought I theorized if I hook an antenna to a board and then run a USB cable from the board to my cell phone, except you have to have an on-the-go adapter cable, which looks like, see, view, speaker view. So it looks like this. It's just a little short cable that I want in. This one happens to be USB-C. Depending on your phone, you can also get one that's a micro USB connector that plugs right into your phone. And then this is just gives you a standard USB host type port. And this is just a cheap cable from Dollar Tree, I think is where it came from. So I paid $1.25 for it at the time. So I theorized if I just hooked those together, that the cell phone would power the board and everybody would be happy and it would run. And then I was digging through the Ardusimple website, and they've got one of their pages says, oh, how do you run our board with your cell phone or tablet? And their steps say basically, yeah, do what I just said, and it should work. So I finally got around to trying that. I was sitting in my chair, and I put an antenna by the window and had my board on my lap and hooked up to my cell phone. And sure enough, let's see, is it worth doing this right now? So here's here's the thing set up right there, and I'll make sure my cell phone's powered up here. Oh, Samsung's trying to help me out again by trying to shove something down my throat here. So let's see, go back to here, go back to here. So this probably won't show up, but this is a program called GNSS Master, and its whole point is when you start it up, it will provide you can connect to the internet and get correction data, and then shove it out the USB cable down here to your board, and then whatever's coming back, you can display on it. There's a status page here. Come on. How come it's ignoring me? There we go. So bring that up, GNSS status. So you can bring up a status screen. And again, I should get a different camera and put up here to up close so you can read this stuff. But anyway, it just gives you lots of things. It says the top's got the time and the date. It says fixed type is invalid. It gives me latitude, longitude, and the altitude. And it gives me UTM XY offset. So they're huge numbers of meters from somewhere, probably Greenwich, England. It tells me my speed, number of satellites in view, satellites in use, the dilution of precision, And it's got some other things at the bottom. It says latitude error, longitude error, horizontal accuracy, and vertical accuracy. And if you go here, let me got to this page, introducing that. Let me find this for you here. Well, it's like, of course, they're not going to show me that screen. They're showing me. Well, yeah, there it is. Okay, so let me say share screen, and go to this screen. And if that's showing, then over here on the right, can I do this? Yeah, that worked out really well. Let's try this. Oh, none of this stuff works. So I guess we won't do it that way. Let me back up and say, oh, what was that? There we go. This is what. Stop it. Well, maybe I can't show you this because it just doesn't want to play the game. Click here. Open a new tab. No, I don't want link. I want image. Well, maybe this isn't worth doing because it just doesn't want to play right now. Oh, that there now it came up just to make me mad. Now, if I click on this, now I can't scroll here. So this is just, oh, there we go. There we go. So anyway, this is the status screen on the left here. That's the status screen. So it's showing you, here's the date and the time, and then it says latitude and longitude and some stuff. Here's the number of satellites used. And then down here is your dilution of precision numbers that, the standard stuff you get on a regular, like a maintenance program for any GPS receiver. So it's telling you all that stuff, and that comes right up on the cell phone. Or you can pull up this one that shows you the number of satellites you're looking at. So I've wasted enough time with that. Let's do this. And I'll just leave that up there and say stop sharing. So the point is, if it's running like that, here's my status screen. If I back up a screen, so on this screen, the connection screen, let's see, this should work. If I take this outside, I got to go through the whole thing and say turn off my Wi-Fi and turn on my cell phone data. But if you watch the board up here, as soon as I plug this in, so we get two lights that come on. This one right here is the power light, and this one is the RTK light. And for some reason, the RTK light is backwards on the board. They should have soldered the LED in the other way. That'd be nice if that focus better too. But anyway, if we sit here for like 30 seconds or so, there's another LED right here that will start flashing, and that says it now has enough satellites in order to. Oh, I got to connect to it. Let me hit a button here. Connect. Go. We're connected. Now if I go back to the status screen, status. So now it's telling me now the numbers are updating and the fix. Now it says the fix is single, which up at the top here, if you could barely read that, it says single. And now it popped up with latitude and longitude here. So it is actually working. So if you look at the board over here, there is a extra light that's flashing right there. And it doesn't focus because they're too close together. So if I back up to my connection screen again, connection screen, that's this one. I click the button to say connect to my Intrip server. And it says we are connected. So if you watch, now already that bottom light has started blinking. The RTK light is blinking. So I go look at my status screen and it should say, it now says RTK float. So yeah, the third line from the top there says RTK float. And again, it's showing me everything else that I had. So already, and keep in mind, I'm in my basement with a ceiling above me, another ceiling above that, and a roof above that. And it's just instantly when I turn it on, it says I got an RTK float. So that's a good thing. So if we sit here for a while, and while we're sitting here, I'll just bring up another screen just for fun. Sky plot. So at this point, it says it thinks it can see this many satellites. And if you look at the stuff hard enough, it'll say, here's how many satellites it can see, and then how many it's actually using. So that's just another fun thing that all this stuff is just available right on the cell phone here. So if I go back to my status screen and say, show me. So right there, it is giving me my current latitude and longitude. So if I move that around, those are live numbers. And you can see the numbers here, the lower digits are changing a lot. But again, I'm inside of my house in my basement, and you have to expect that. So, and it still hasn't acquired a fix yet. In my living room, I can get a fix within like a minute or two. And now in the basement, I may or may not get that to work. But the point is, I hook up the phone and it's working, and I can see what's going on. So at this point, I can just take the thing out and walk around in the yard and stick the pole on the ground, and then look at my status screen. And look at my status screen. I can get the actual latitude and longitude of where I'm at. So that was the first thing I wanted to be able to do. And then I did some more digging. You can get something called SW Maps, and that's again documented on the Ardusimple webpage. This software I'm using right now is on the Ardusimple webpage, and you can get the SW Maps. They document it there, and that one basically is doing the same thing. I've got the same status screen, and I got the same interrupt client, so I can do the same things I did here. But then when you go back to the main screen, it shows you a map, so you get a map of the world. And if I click the right buttons, it would probably automatically zoom to my location, but I just had to manually expand it out, slide around to the other side of the world, and zoom back in. And then once you get that, it puts a dot on the screen. So as you're walking around, you get this dot so you can see where you are. And the color of that, if it's green, it means you have RTK fix. If it's yellow, you have RTK float. I think red is the single point. And if it has no connection at all, I think the dot either goes away or it'll be a non-filled in dot that doesn't move. And that one, I played with that one a little more. And you can, I found one option. I go to the record menu and say record a photo. If I click on that, it brings up my just the standard cell phone page where you take pictures of things. So you point at something, hit the button to take a picture, and then it comes back and says, do you want to retry or is that okay? So if you click OK, then it goes back to the software and it puts a box here. Maybe I can, I don't know that software running. Here, let's do this. Let me bail out of this software and bring up the SW map so I can show you. Let's see. So I'll go here. Let's do this. Just shut it down completely. Come here. It says continue with project 1. Yes. So this one, when it comes up, here's a map of my. That's going to show up. There's a map of my neighborhood right there. And those little squares on there, that's where I've gone around taking pictures of things. So this one in the upper corner here, this is an actual surveyed location with an official marker there. If I click on that, then it brings up this screen. This is the resulting screen if you go through. Come on, focus, focus. Well, that's not real handy. So anyway, here's the photo that I took, and then down below it says latitude and longitude and elevation and bearing and a time. So it ties those things together. And I just assumed that when I came back in the house and went to my cell phone picture directory, that it would have the picture and the text on it, but it doesn't. It just has the picture. So somehow in the software, they're tying that stuff together. So I think there's a button I can say export, and it will take this stuff and send it out. I think it writes it to a file on the computer, and you have to go read that up somehow. But anyway, let me back out of here. Photo. So anyway, these are various points. I walked around the yard and took readings at places I thought were important, like down here at the bottom. There's a street running this way and a street running this way. And so I went out, stood in the intersection and got a mark. And then this point down here is this is where this second one here is the bottom one is the street, and the next one up, that's the point in the yard where my property marker was supposed to be. And I actually went out and spent like 2 hours digging in the yard until I found it. So I know that point, and then I know the points in the street. And I can't get any of this stuff to line up. If you go on on the online mapping programs and you say, show me the latitude and longitude, it gives you a number. You go to a different mapping program that'll be in a different spot. If I go out and actually measure it in the yard, I get a number and paste that back into Google Maps, and that doesn't line up. So none of the stuff lines up, and I don't know why. But anyway, it seems like I can Let's see, I don't have my Interp client running, do I was just looking to see if I had an RTK fix yet, but I guess I got to go through more menus on the, since I loaded new software, let's go back in here and say USB serial, say, yes, I want to connect. Instrument height is 0. It wants me to put in the length of my pole, so I can add that on to the values it's coming back with. So let's see, how do I get out of this now? I'll do this. Oh, so I'm talking to it, but now. So once I connect now, again, you're not going to be able to see that, but there's another button here that says Intrip Connect. So I click on that and say connect. And then instantly my light is flashing here, that, and you can't see it. There's two lights flashing now, so it makes it hard to see. But it now, as soon as I did it, it says I have a RTK float solution. And if I go back to the status screen, it would tell me that. So that's another method I have. I can walk around with this thing and just put it on the ground and then read off the latitude and longitude. And then so I don't have to, because the problem is, see, I have to go out and hold on to the pole with one hand like this, hold on the cell phone with my other hand. Then I have to have a notebook in my other hand and then have a pen in the other hand and write all the stuff down. So once I found out I could click on this thing and say, take a photo and then pin the current latitude and longitude to it, that solved a lot of problems there. But I'd like to find, if I can find a cell phone app that will also let me go to a known spot and then push a button to say, make this the origin, just like we do on the robot stuff, but drive to a point and have it locate that. And that will become 0, 0 out of my yard. And then as I walk around, it'll give me an offset in either meters or feet as I walk around. And then it'd be nice just to have one button. I push the button and it would save, all my locations to a file or something. So I don't have to, so I really don't want to go through this photo thing either, because that's another like 5 or 6 steps to do that. So if I just had a button, I can push it and say, save this location. And that way I could save it out to the, some kind of storage and then pull it back later to see what that stuff is. So that's kind of where I'm at right now. If I can find a better cell phone app, I could put it on here, and that will, if I can get it to do everything I want, then I'm all set. Otherwise, I have to do, I thought I could put on this thing here, put a Raspberry Pi on here, and then load up Linux, and then have something that reads stuff out of the board and then processes it like we do on the robot. So it says, we know where the origin is. It gives us distances, and so by adding yet more crap on this pole here, I could do that. It's just that's going to be a pain to do all that stuff. So then other things. So building this thing on the top here, this monopod just has a 1/4 bolt sticking out of the top, and you're supposed to screw a camera onto that. So instead of that, I got this mess here. I got the antenna, and then this adapter goes in there. So this bolt sticking up represents what's on the monopod. And here's another one here. So that once you screw that on, so I can just take that and just spin it onto the top of the monopod, and then that's secure on top of there. So it's like on there. And then I had the cable coming down, so it just got the loop of antenna cables rolled up, and I just put a tie wrap around here to hold at the top. And since it's in a crack, it can't move up and down. I put another one bottom just to keep it from flopping around. Then to mount the board, I just simply, it originally had like a carrying handle, a carrying strap on here. So I took that off, and it just gives me a hole there. So I just put a piece of wire through it and twisted it, and then stuck it through the hole on the board. So on a standard Arduino, here's one of the mounting holes, and I just simply put a wire through there and twisted it. So the thing is just hanging like this on the pole. And then to keep it, see if you look at it, see it's kind of moves around like that. And then down at the bottom, I had the 2 cables coming out. I just put a tie wrap around to keep those from moving. So that keeps it from the bottom up from moving around. So that was secure enough to go out and test it and try it out. But I thought in the future it'd be nice to have a better way to mount that. So I bought this plastic box on Amazon. And here's just a standard Arduino for size. And see, it drops right inside there. And then I've got a clear lid that goes on top. So with that, I should be able to see the LEDs blinking inside. That's why I wanted it clear. And it's got the tabs on the box, so I can, if the pole is here like this, I can put some kind of strap around to hold that on. So it would go on the on the device, just bolted on there, and then the board would be inside of it and then be somewhat protected. And then again, it's just got the cable. It just has the USB cable coming down, and it's all wrapped up now. And essentially, it's just just a cable coming out and plugs into the cell phone. So that's all I'd really need. And again, back to my point that I need 4 hands to do this. Well, then I decided if I'd mount the cell phone to the pole. So here's something I bought on Amazon that's supposed to be a cell phone holder. And if you push the one button on the back and it opens up like that, and then the other button that drops down. So I put the cell phone in here like this, and then squeeze it. And now it's in there solid enough that it doesn't fall out. So I think if I just figure out some way to get this attached to my pole, then everything would be in one thing. So just one hand would let me hold on to the pole, and then I can see the phone, and then use my other hand to poke the buttons on the phone. So that was kind of the evolution of all that stuff that I did there. And I had some other pictures here, maybe worth pulling these up. Let me go back to here, share screen. Here. So this is those adapters that I bought on Amazon. This is the plastic box I bought. I say I paid like $7 for it. You come down here looking, you can pick different sizes. So I've actually got probably, I think it was that one that I bought. And anyway, as an Arduino board seems to fit in it adequately. So that's a good thing. And so it's just gonna be a matter of figuring out how to mount that. I'll probably just bolt it to a little plastic plate and put straps around it or something to hold it on. And what was this one? I think it's just the cell phone holder. So it was $8 for that thing. And when I was looking at the pictures, I thought, well, if I have to, I can take a hacksaw and cut some of that off, and then glue it or strap it or whatever to put it on the pole. So I think in general, just for a general measuring device, I can take this out in the yard. So on your robotics, if you say I want to start at point A and go to point B, you can go collect all these locations. Because that SW Maps also has a option called record tracks. So it's kind of like on any other GPS software. You're standing somewhere, you say record tracks, and as you walk around your yard, it records all the points as you say, like what Al was doing, trying to get the outline of his yard. You can just walk around with that as opposed to driving the robot. Now, you still have the option, like he did. He's got a GPS on his robot. He just manually drove it around and recorded all the points. So it's basically doing the same thing. It's just that it puts it on your cell phone, and you don't need to have the full robot out to do that. So that's pretty much the story I had on that. Let me go back here and see if I see Windows again is going to be real slow at switching screens. I'm still sharing. So there's this is the so that's a patch antenna I got now. The previous one was about half that size. The original single band antennas back for the M8T and M8P type boards. This is what this is that adapter. This is one you can pay a lot of money for if no, that's the antenna. So that anyway, it's just another survey grant. So I got 2 of these now that came from Ardusimple, and the first one I bought came directly from China, and they all seem to work. I also haven't figured out how to compare the survey grade antenna to the new patch antenna. So again, here's that expensive adapter if you really need to get one of those. And this was just showing the all the screens on that GNSS Master program. So they're just telling you how to run it here. And this is that image that didn't want to work. So I just want to see if I had went through all the pictures that I had up here. It looks like I did. So anyway, that's what that project is. I've tried to measure, go out in my yard. I was trying to find property lines. And if I can dig up a thing and find a survey marker in the ground, then I can measure out 120 feet to find the next one. So I measured it and put a line on the sidewalk, but I have to verify. I actually have to dig it up to find the actual pin that they put in 50 years ago, and then that will be the official spot. So if I put my GPS receiver on that, say, what is this location, and then walk to where it says the next one should be and see, you know, and see where does that point show up on out in the world. So I just put a mark there. So then if you just simply look down the line or get a piece of rope, because it's I think 180 feet in that direction, you get a big long rope, you could run a rope the whole way and find out where the property line runs across the yard. And then there's a question about does somebody's fence go across the property line or whatever. So that's kind of where I'm at. And to add to that story, I was saying last week that didn't get recorded, that I finally got fed up with. Once I started thinking about using a metal detector to find these pins in the ground, I kept looking at that and looking at it. Finally, I said, "Oh, screw it! I'm just gonna." Even though I didn't want to spend any money, I did. So I ordered the cheapest one I could find on Amazon. Stop sharing, and it looks like this, and it was like $32 I paid for it, and it just has a little dial on here, and it beeps when it finds something. But the problem is it won't read deep enough into the ground to find the stuff that I know is there, because I have the one pin I did dig up was 11 inches deep, and this thing just doesn't register anything at that point. So basically, that's not going to work for me. So I was looking at, I still haven't got this off my mind. I keep looking at YouTube videos on how to build these things. And so I may end up building one from scratch, or just simply go out and start digging in the yard, because I know basically where this thing should be. And I know closer than the first one I did. The first one I was kind of guessing at where it was. This one, it should be on this line and on this line. And if it is, then I just have to get a shovel and dig down until I find it. So that I may do that and not go back to the metal detectors. So I'll see what happens on that. And I was trying to think of anything else related to that or anything else that I did. And oh, and so I was looking at metal detectors. I finally found, when you first start off, you find all these people that say, "Oh, I use metal detectors, I sell metal detectors," or "I'm an expert on them because I look at them and I want to get you to buy stuff from Amazon and give me money." So you get all these people that really don't know what they're talking about, but they just go on and on and on. They get hundreds of videos, and then after a couple of weeks, just going through searching for stuff, whether it's on YouTube or probably just on YouTube does this, that you eventually find it'll start giving you better stuff. So I found one where a guy was building his own coil. This is the first time I saw somebody hook an inductance meter up to his coil to find out what the real inductance was, as opposed to guessing at it, which is everybody else is doing. And then later in the video, he says, "Oh, and here, if you bend the cable back and forth, or the bend the coil back and forth, you can null the thing out." So he had a little oscilloscope set up, and you could see a sine wave on the top and a sine wave on the bottom. And as you move the thing back and forth, you can see the amplitude of the bottom sine wave would get larger and smaller, larger and smaller. So the thing is, you're supposed to get that down to a fairly small number and then leave it there. And he had a clever thing. He had a plastic screw in from the side. As he'd screw it, that would bend the coil in and out until you get just exactly where you want it. As opposed to other people are just guessing at that and moving stuff around. So while he's doing that, I ran across another video where they have this real cute little gadget that in the video it says transistor tester on the thing. And if you go look on Amazon, it turns out you can buy this thing. It's a clever little thing that people have put together. It's probably an open source device, and you can get as cheap as $12.99. It's just a PC board and not in a case. You hook up a 9-volt battery and it works. Or you can get it a mid-range. It's got actually in a plastic case, or you can get the tall case that's like $39.95. So you got a whole range of prices, but they all seem to do the same thing. So I ordered up one of those, and I ordered the mid range around $20. It comes in a case with a lithium battery built in, and this thing will measure capacitors and resistors and inductors and transistors and LEDs. You just plug them in and say go, and it says, "Oh, I see that's an LED," or "I see that's a transistor. It's an N type with a HFE of 150 or whatever it is." And then you plug in an inductor and it says, "Oh, that's 160 microhenries," or whatever it is. So I ordered that, and it's supposed to show up today. So just, if nothing else, it'd be fun to play with. And I was looking at all of my digital multimeters thinking, well, I got a couple of flukes. They will probably measure inductance. Well, they won't. And my cheap ones from Harbor Freight won't do it. And my cheap one from MPJA won't do it. So I went ahead and ordered this one for $20. And as I said, it's supposed to show up today. So I can try that out, and that may or may not be useful for other things. So I'm looking at my share screen. No, I don't want to share screen. I'm going to stay on this one. So how do I get out of here? So I was looking at my lights over here, looking to see if I have an RTK fix, but I don't. So apparently in the basement, it's just too much attenuation for it to finally lock on. It's not exactly vertical. Maybe if I move it vertical. But if I take it outside, it just seems to work great. So that the fact that I'm running in the basement, the fact that I can get an RTK float to start with is impressive, but I can't get the RTK fix. So that's just where I'm at with that. And I'm going to keep looking for new cell phone data that will, or new cell phone app that hopefully I can get one that will give me, in real time, show me my offset from my reference, and then just have a button to store the stuff. And then I'll be fairly happy at that point. So I'm going to stop babbling now, and I'll say, are there any questions on that? Go out to our massive audience and say, are there any questions?
On the antennas, I saw that they were, advertised as multi-path. So they're L1, L2. Do you know if they're also like all the other European and Russian and Asian
They
brand?
they will do the ones I've got are L1 and L2. Now it turns out L2 has more than one like sub band, but I believe these antennas work for whatever I have. They seem to work for whatever I have. So the ones I have are L1 and L2. Now it turns out they got new stuff out that's L1 and L5. And I'm not sure if this antenna will work for L5 or not, but they do work for this. This does four constellations. You get GPS, GLONASS, Galileo, and Beidou. You can also get a Japanese one, but they say the orbit is such that from our part of the world we can't see those anyway. So yes, I can get all four satellite constellations, the major ones. And it turns out I really should go in and turn off the Chinese Beidou one because my correction server that I'm using does not give me correction data for that. So I'm thinking that having extra satellites with no correction data actually makes my results worse. But I just took it out of the box without any configuration, plugged it in my cell phone and said go, and everything is just working at this point. So back to the antennas. Now they come up with the new triple band one that's L1, L2, and L5, and you buy that Septentrino module, but it's like $600 or $700 as opposed to this board I've got now. This one is $200 for this board. So if you do that, then you're going to have to get either two to create your own base station and a rover, or you have to find somebody's correction data that puts out all the modern stuff. And I don't have access to that. So number one, I didn't want to spend any money on this one, but I did. And I certainly don't want to spend, 2 or 3 times more to replace all this stuff for the really, really fancy ones. So the problem is, as I said, this one runs L1 and L2, and it uses the standard sub band of L2. And then when Swift Nav came out with their stuff several years ago, they're using L1 and L2, but their L2 is using a different sub band. So that causes problems there. So they're not directly compatible. Although I was able to take one of the Swift Navs and set up as a base station and then talk to our Novatel, our $20,000 Novatel receiver on our tractor at work. And I was able to get that to give it enough correction data that I could get an RTK lock on that. So that was just one example there. So you just have to look at all this stuff and see what matches and what doesn't.
And I realize you're not necessarily worried about the rate publishing the NEMA sentences with the sort of walk around stick, but do you have any idea what the capacity is of that board to publish? How fast will it publish NEMA data?
Well, this one, if you run that software that I was talking about, it just has a configuration screen, and they give you the option of 1 hertz or 5 hertz. So it's probably set, the default when it comes out of the box is set at 1 hertz, I think. And then since I'm using the same board on my robot, I know that you can run at 1 or 5 or 8 hertz. Somewhere it said if you run 8 hertz, you can still run all four constellations. Full out. You can run run everything at an 8 hertz rate, and then but somewhere else I saw they said, well, you can run everything at a 10 hertz rate. So theoretically, I should be able to set it to 10 hertz and run it. And then it says, I was thinking if you go to 10 hertz, you have to drop off one of this satellites, constellations. And since I want to throw out the Beidou anyway, then theoretically, running GPS, GLONASS, and Galileo, then theoretically at that point, I can set it to a 10 hertz output rate. And then they said, if you really want to, you can turn off everything except GPS. And when you do that, it'll put out a 20 hertz rate. Um, you know, I don't know how good the solution will be at a 20 hertz rate, but it will. If you need to get the faster rate, you could indeed do that. I had one more thought on that. Let's see, blah, 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 blah.
My recollection is it takes about 8 satellites to get RTK. My assumption is you definitely are going to have 8 satellites if you got a clear sky with L1 and L2 only, wouldn't you think?
Would you have L1 and L2 or just L1? Yeah, you can get, you can see like 20 GPS satellites. You know, it'll say I can see 20, and it'll usually end up using somewhere between 7 to 14 or something in a normal solution like that.
So to get 20 hertz, you got to turn off all of it, but L1 and L2 is what I'm hearing.
Well, again, L1 and L2 has nothing to do with it. It's the processing power on the chip itself. The more satellites you're trying to track, the slower it runs, and that's why it does that. But they're saying if you run, I think it says if you run up to 3 constellations, which is probably almost 30 satellites you could theoretically see. They say it can process that at a, I think process that at a 10 hertz rate if you really want to. Or you can just turn off everything except GPS, then possibly it'll output at a 20 hertz rate. But my other problem, well, that's what I was going to say. The other problem is once I put this second receiver on to give me my my moving baseline, which gives me my static heading, then it starts getting touchy again about, you know, how fast can you publish on this one and that one, and something had to match. So I finally decided it was just easier. I left my back one that's RTK, I left that set at a 5 hertz publish rate, and then the front one, I don't remember, that might be running at 1 hertz rate or something, but just to get the static heading, it doesn't really care what that is. So that it's just a matter of playing around with this stuff to get everything to work.
On yours, are you calculating your heading using 2 different NEMA sentences from obviously 2 different receivers?
I'm not calculating it. I simply go into the, you hook 2 of them together. So you say, you output correction data from the first one and input correction data on the second one. And the only trick is you have to go into the first RTK receiver and you say, I want to output correction data. So you say, turn on, like normally you turn on like 3 or 4 RTCM output messages on just a standard base station. Now, if you want to get the moving baseline, you just add 2 more into that list, and you don't have to do anything on the receiver one. It just simply says, "Oh, I see extra data," and it just automatically internally does that calculation for you, and then outputs a number. If you pull up the right message, there's a number, and they're supposed to be accurate to within like half a degree. They say if you have a baseline of 1 meter, it'll output approximately a half a degree accuracy on that heading. Mine's actually shorter than that because my vehicle's not big enough. So mine's like 3/4 meter, and the heading always looks good, and that's about as extensively as I have tested that.
And you have an earlier version of the Ardusimple GPS receiver on your, I'm going to say tractor, right, on your robot.
So ask that question again.
Which GPS receiver do you have on your robot?
Well, on I've got 2 of the U-Blocks receivers on there, and the one on the front is the original one from their Kickstarter, and I've decided that one doesn't seem to work quite as well for some reason, and the one on the back I think is identical to the one I just bought. So depending on the version of the board, there may be a difference, or it might be my imagination, or maybe just their component selection on that first one wasn't working as well. But yes, on my robot, I've got 2 U-Blocks receivers. They're identical except for the version of the board, and that's what I'm using on that.
And then the cell phone software, GNSS Master, is that Ardusimple software, or they just referenced it on their website?
I think they're just referencing that, and I don't know but if you dig through it, it says about, oh, here's a configuration. Here's how you can configure the board from the software. So it's got both for the board I've got, and it's got the also the triple band receiver, your two options. And so it could be that they are actually maintaining that. I'm not sure. But that SW Maps is somebody totally different. And that one, I don't know who wrote that, but it's just anything you can download from the Android app store and load on your phone. You can run any of that stuff.
And you
And
found SW Maps on the Ardusimple website as well?
yeah, if you go to the Ardusimple website, they do talk about that. And if you go out to YouTube, there's lots of people talking about it. And when I'm done here, I'll put all these links out in the info chat section, that where to find this stuff. I just before the meeting, I was trying to pull all this stuff up, and I couldn't find that one. There's a couple of references I couldn't find, so I didn't put those up. But y'all put those up so you can go dig through those if you want to know that.
And then
And
finally, you used your stick yet to get a reading on a known location to compare lat longs?
yes, I have. I went back to here. Let me see if I can bring this up here, because
There was a
that's
there was a
that's
picture in the top left corner of one of your screens that you said was a survey point.
yeah. So if I go out to that one and pull up the first one, no, I have it written down. So I got a notebook somewhere here, and
But just generally, wow, how far off was it?
well, see, that's the problem. You go look at it, and I get a number, and I I haven't figured out how to equate a latitude to an actual distance. So here's my notebook, and it says the latitude of that survey point was 45.0129230. If I go to this one, click here, photo, second photo. So it says it is 45.1292317. So one says at the end, let's see, that's 1, 2, 3, 4, 5, 6. So in the sixth decimal place, one of them says 30, and the other one says 31. Do I have a different number? 7, 8. So one of them says 30, starting in the, what did I say that was the 1, 2, 3, 4, 5, 6. In the sixth position, it says 30, and the other was in the sixth position says 317. So the problem is I don't know how to determine what that is. I found a chart somewhere that says this decimal point equals so much, this decimal point is so much, and you get out to like the seventh decimal point, and you're like 0.11 meters at the equator. So there's more stuff confused here, but I decided it looks pretty darn close, considering this was done like a week apart or 2 weeks apart, and then I have the other point that was out my front yard. Again, I wrote that one down, and I went out and just measured that one. And let's see.
Code that will do that calculation. Uses a Python library called geopy.distance.
It's called what?
Geopy.distance.
You don't happen to have a reference to that handy, do you? You can put in the chat.
Oh crap! It says my thing is too long.
If not,
Yes, I do.
you said it twice, and I can go look it up. So you're, and my other point in my yard, it said 45.01.22.673, and this one says 45.01.22.6283. So one says, let's see what this is. It says 673, and then everyone says 6283. And again, that was several days apart, and I measured it. So if I knew how to calculate that, I could tell you. And then like right now, I could go out in the front yard again and check it again to see what it says today. So, but like the stuff you're talking about it being off several meters or whatever. No, I don't think I've ever seen that. And right now it looks fairly close. And but so it'd be nice because these last two that I was just quoting that I went out and checked, I was fairly accurate about. Again, you probably can't see this, but so here's the photo. Here's my pole coming down to the ground. I've got an X painted on the ground. What if I just unplug this? What's it going to do?
I
Okay,
just
there
put
we
in
go.
that 2 code snippets. If you put those together, you'll have a full program to calculate the distance.
Okay. So there's the photo that I took, and I see I've got that X painted on the ground. So right in the
Cool.
center of that X, I had a like a fiberglass pole stuck in there. So I pulled the pole out and put my new measuring stick right on that same point. It's focused a second ago. That didn't want to play.
Who put the fiberglass stick in that you pulled out?
I did after I
Oh,
after I dug down there. There it's focused. So see the pole. I just there and it being a camera thing, it's got one of those things a foot that you can screw in and out. So if you screw that up all the way, you got a point sticking out the bottom. Or if you run it down all the way, you got a flat foot that you can put on a floor like in the house. So I've got the point of that stuck in that hole right there. And then so at the bottom you can see the numbers coming up, and that tells you. And this is actually that's because there's more resolution than what I had before. So on the robot apparently wasn't putting out as many digits as what I'm seeing here. And then I noticed if I go on my U-block stuff, instead of going to the NEMA sentence and whatever GPS fix is putting out, instead of using that, if I go to a message called nav PVT, in there it's got the latitude and longitude, and they're like 12 digits long or something. It's a big integer number, so you have to figure out where the decimal point goes. But so it's got, and somewhere in the U-block stuff you can say turn on high precision. So there's various things. If I pay attention to what I'm doing, I might be able to get better resolution and just figure out how to do this stuff. So after I'm done with this stuff, I'll take your thing you just posted there and go try that stuff and see what I can do. Because I thought I could just write my own calculator to just take that same LL to XY that's in that Python stuff that we use on the robot stuff, and I could just write my own calculator that, number one, you'd say convert that latitude and longitude to an offset, and then you should be able to just add any arbitrary distance to that. And I think there's another one called XY to LLs that'll convert it back. So I could just write a calculator that would actually do that stuff for me. So I haven't played with it to find out if that's going to work or not, but that it seems like that should on the robots it seems to be working well.
cool.
That's all I can think of right now. That's what I've been playing with, and that's kind of results I've been getting, and so that's all I got for now.
The last thing I put in there was just the URL to the actual program, and it took 60 seconds to look it up. But yeah, you can go put 2 pieces together, or you can go to the URL and have it all in one.
Okay.
Let's see. Just a little bit of update. Last time I spoke about so this is my Miro board. Just as a reminder, I've got a single GPS receiver on the tractor, a single GPS receiver as a base station. I had trouble that, I agree with Jeff that he had said, you got to let your base station settle down and stop moving around. And I had not paid enough attention to configuring my base station GPS, and I had it on what's referred to as auto mode, which meant that it was simply calculating its location over time, and that provided more variability. So these are some of the settings in my base station. And that fix auto means that every time it starts up, it's going to go calculate where it's at. And instead of letting it run for a few days and then averaging all that and programming that in. That's what I intend to do. So I'm on a mission to change the configuration of my base station from fix auto to fixed, I think is the statement, and you give the actual lat long.
Well,
And that will,
while you got that screen up right there where it says logcom RTCM 1004 binary on time one. It's those to get the moving baseline to work, you just have to add two more statements to that, and they're like a message numbers like 4067 or something. But they're just all I have to do to get my moving baseline to work is to add, I think, two more output messages and then connect the two receivers together. And then my second receiver just automatically says, oh, I see moving baseline correction data coming in, and it does the correction for you.
yeah, I mean, at some point it would be interesting to see physically how I mean, is that just a USB cable, or do you actually have to like connect some UART ports between the two?
I am using the UART port, and it turns out on these U blocks, you've got a USB port and two UART ports, and you can use any of them. I think you can use any of them for anything you want. So it's just a matter of what's convenient. Since I was already using the USB to talk to the ROS computer, I just had the two UARTs connected together with just physical wires.
Because I was interested in heading, pun intended, heading down the heading route. And I'm thinking, oh, well, I'm going to have to spend this $600, like you said, to get that single receiver that's got two antenna ports on it. But anyway, one step at a time. So I didn't remember exactly what all of those correction statements, sentences meant. So I also added to this a little bit of a description. And I'm not sure, as an example, why I'm even publishing this 12B, because it's associated with BLAWSMAS. And I was looking at this one, this 108B, and it's got an antenna descriptor statement, but I'm like, well, I never set that. I don't know how it can have an antenna descriptor, because I mean, you can see in my configuration, I start with a level, I'll clear the thing out. Anyway, so it was a little bit of interesting. And there's a receiver and antenna descriptor, which I get it, that some of that is just going to be like, where are you and how high is the antenna? But I'm not sure I've configured all of these correctly, because as you can see, I don't have, it's not automatic. I haven't added anything to the configuration to provide some of that stuff. So bottom line is I need to make sure I've configured my base station correctly, in addition to getting the actual lat long position of the base station.
Scroll that back up the top, that block of stuff you had again. Okay. Now, one of those is for the this is just documentation. It's one's for your base and one's for your rover. I saw you had the unlog all twice. I thought, well, if you do it once and do it again, that wipes out the first stuff. But I see this is two separate receivers you're talking about here.
Roger that, yes.
Okay. Another comment you're saying, well, if you buy more stuff before you actually buy it, let people know what you're doing so people can look at it and decide if make sure you're not just confused on something and end up with more stuff that's not going to do what you want it to.
Yeah, for the moment, I get RTK fix on this one on the rover, and so I'm reticent to change anything, but I definitely know that I want to change the fix auto to a defined survey a point and put the antenna there. So anyway, I had a kludgy solution for my base station, so I'm changing that in order to put it in a box, weatherproof box. This is what that looks like at the moment. There's still got more to do. There's an antenna connector that's coming out here. That little purple dot. I hadn't 3D printed anything in quite a while, so I didn't have a nut to go on that antenna connector, so I 3D printed that and took time to get my 3D printer back up and running and the software needed to run that. So that's where I've spent most of my time. I was going to put maybe a Raspberry Pi or something in the bottom of this so that I could get a little bit more data off of this. Like there are 3 COM ports here. Can't see the third one. It's underneath this radio. So anyway, I thought I would use that real estate to put in an RPi. And I was just going to jam in 12 volts here, which then runs the receiver. And then I also can't really see it, but there's a 12 volt to 5 volt converter there, which is running this radio, which needs 5 volts, and the 9-pin UART converter there. So spent a little time on that. And then also spent some time on a Jupyter notebook going to help create my path. And the point where I'm at the moment is I can pretty much, without manual intervention, as Jeff said, boy, and I got to say, walking the path and capturing points would be a whole lot probably easier and faster than driving the path. But so I definitely want to get to that point. But once I have a perimeter, I can generate the interior lines. I can take an obstacle and calculate on the perimeter path the workaround. But my next step is, you can see a circle there and lines going through that circle. That's a bad thing. That circle represents an obstacle. So I'm still in the process of adjusting my obstacle code to handle these, what I'll call stripes or Ostrophin path. So anyway, that's where I'm at. This Jupyter notebook, by the way, is along with all my other stuff up on GitHub. So a little bit of progress, slow but steady. I want to get the base station settled and improved in order to hopefully reduce the variations that I saw when I ran my last missions, when it was no snow on the ground and 50 degrees outside. So that's where I'm at. Do you have any idea what well, you're using corrections data, but if you had a base station, do you have any idea what's the least number of RTCM statements you have to configure a base station for?
It seems like there's like 4 that everybody uses. And if you look somewhere, it'll say, here's how you configure your base station. So probably in your manuals that you have, there should be a section that says, here's the suggested way to do that. And I would just take whatever they give you there and put that in there. As far as turning on the messages. Now, as you're saying, there is talking about your defining your antenna height and all this kind of stuff. That's just other stuff that you have to, go to somewhere else in the configuration and set that stuff up, I think, but I'm not sure how that works. But I think there are tutorials on, setting up your base and your rover, and you can get it for different brands. And since your stuff emulates Novatel, just look for tutorials on new Novatel to do that. And that should, tell you what you need to know there. And whether you find it in somebody's manual or somebody's write up, or just go to YouTube, and they might, say, here's how you do that. Here's how you set up, here's how you set up your base station. And so there's probably lots of information out there on how to do that.
Cool. That's all I've got for today.
Okay.